What's up, y'all?
No skin scientist.
Something just happened. No, there's been raining.
Cloud burn.
No, I've been wearing
Maybe
long sleeve shirts.
you've been
It's
exposed
just so
to
hot.
some acid. I don't know.
Yeah, you can get from right.
Yeah. That's what I get worse at. Because I don't have sensitive.
Maybe you have skin cancer.
I don't. I get checked every so often because it runs in my family.
That's a good thing that you get checked.
Skin cancer's not that.
They just burn it off, or they just take it off to scrape it off.
They can
Yeah,
burn it.
that's a good thing.
And then I have it on his face.
It's not like you have like lung cancer.
Yeah.
Okay, let me just scrape that lung off real quick.
Lung cancer's pretty much, yeah, you're gonna die.
You need to replace the organ, basically.
That's something. Die.
No, you can. The only one you can replace is
Replace my brain.
no, I mean the whole line. It's a pretty recent
You'll wake up and be like,
You guys get that there? 0.1611?
Yep.
This is the one where you get. And then good old probability of at least one. Now you could, if you wanted to, you could do the formula for x equal to 1, the formula for x equal to 2, the formula for x equals 3, the formula for x equals 1, all the way up to frickin' 44. Completely valid, you could do that. If you do that, I'm a little worried about it. Or you do 1 minus the only thing that leaves out, and the thing that we already calculated. That's the power of that shortcut. So 1 minus 0.0007. 0.9993. Second? Understand which part? Sorry. What about it? This is 0.0007. That's the better way to write it. That's the same thing as 0.0007. That means is that 5? I know. But that goes in the C. At this point, if you're still not clear about this idea, come see me. I mean, I don't know how else I could say it in class. I got to sit down and watch your face as I say things. There's too many of you right now for me to watch everybody's face. But if you come see me one-on-one and watch you until I say the thing that makes you go, oh. Okay. We've already talked about that many times. I don't know how else to say it in class. Probably at least 1 is 1 minus the opposite. The opposite of at least 1 is 0. See, I can't help but explain it again. Yes. All right. Now, part D is the part that I hadn't talked about yet, but I wanted to throw this at you. Those are the most beautiful formulas for those we've seen yet. Do you agree? Mm-hmm. Yeah, there's no table. I just can do it. And why does it make complete sense? Well, what percentage of any group of San Diegans would I expect to smoke? What percent? Period. What percent of San Diegans smoke? 15.2. Yeah, 15.2. So if I had 10 people, I would expect 15.2% of 10 to smoke. I have 44 people. I expect 15.2% of those 44 to smoke. Isn't that exactly what this is? This 0.152 times 44. That's why that is that's the average. It's a formula for the average because that's what I expect. If I make, I used to pick on Shaquille O'Neal all the time, but poor Shaq couldn't make a free throw to save his life. So let's say he made 30% of his free throws. If he takes 20 free throws, how many would you expect him to make? 30% of 20, 6.
that's bad.
Is he always going to make 6? No, that's an average, right? Sometimes you get really lucky and make like 7. Okay, enough about Shaq. Poor Shaq. He actually became a Celtic at some point, so I got a little bit of leeway from me. So this would be N is 44, P is 0.152. So how many would I expect on average? 6.688. I like it. Don't round that to 7 because you're like, well, you can't have 6.68. No, averages never say a specific instance. That is on average that. An average could be anything. Yes? Of course. Yes. They're formulas. All right. And then this is the one that's a little bit beyond our capability at the moment to fully explain. We're just going to throw it in there. Square root of NPQ. What do you guys get when you do that?
2.5.
5.381.
2.32.
I went up to 4 places.
Standard deviation, you always go at least
4.
3 places.
3.
So you start to realize what I said the first day was, or one of the first days. If you take everything out to 4 places, you're basically covered. Right? You just want to make that a blanket way to do everything. Okay.
Yeah.
Hmm?
It's 1.5. So it's
Is it 1.5? I wasn't even paying enough attention. No, it's not 1.5. You guys are so funny. It's not dominoes.
it's 1.4.
You don't knock the 4 up to 5 and then knocks the 1 up to 2.
I
No.
went to 4.
Next to 1 is 4. It's 2.381. Thanks for playing.
Wouldn't it be 2.3 at 1.5? Yeah.
Or whatever
If
you
we make
want.
4 decimal places.
If you make it 4, sure. I'm going to do this because I'm allowed to and I want to.
I do 4 when you do 3, bro. Too many
I love
numbers.
you guys. So are you wrong if you make it 2.3815?
No.
No.
But you're going to
We're
do
more correct.
2.312.
We're correct.
This should be very familiar by now. But this is a little bit different, and this is what I was getting you guys ready for. So now we have a more specific reason to do this. Anything that's more than 2 steps away, more than 2 standard deviations away, we're going to call that unusual. Because actually what that ends up being is within 1 step of a normal curve, there's 68%. Within 2 steps, there's 95% of the data is in 2 steps away. So what percentage would be outside of 2 steps away? Only, if there's 95% in here, 5% outside. So that would be what we consider unusual. That's the most common definition of unusual, is if you have something occur in an area where there's only 5% of your data. That would be what we call unusual. So more than 2 steps away. So if I start there and I go 2 steps up now, 2 steps up, where do I end up? 2 of these. So that plus 2 times this. 1.451. And then 2 steps down.
1.926.
Who?
1.925.
1.925. Is that cool? Yes. So I have to add 2 of these. And then subtract 2 of these. So up 2 steps, down 2 steps. So what's kind of the formula for the max and min expected values? Max and min usual values? The minimum would be mu minus 2 sigma. The maximum would be mu plus 2 sigma. Start at the mean and go down 2. That's the minimum expected value. Start at the mean and go up 2. That's the maximum expected value. This is finally, I don't know if you guys remember, we can actually calculate this now. If I flipped a coin 500 times, in fact, we'll do this next. Flip a coin 500 times, what is the least and most number of heads I should expect? Anything outside of there is possible evidence that the coin isn't right. So we'll talk about that in a minute. Let's finish this one up. There's just one thing we got to say here. So would it be unusual to find 17?
Yes.
Oh, hell yeah. It's way up here.
It's like 4. Over 4.
Say again?
It's like over 4 standard deviations.
Oh, you could even go more specific with how many standard deviations away it is, or just say it's more than 2 standard deviations away. That would be unusual. You guys, so this is how they analyze. If they notice a little pocket, a little neighborhood of 100 people, and they see that their cholesterol is more than 2 standard deviations below the average cholesterol level of everybody, they're like, what is happening there? But that also leads to false things, like the whole cancer pocket. Have you ever heard of the little cancer, like, oh, these people right here, they get cancer at a higher rate
than other people, but I mean, statistically, that's just going to happen. So does unusual mean that's impossible? No. Hell no. It just means it's unusual. Our brains can't really handle it. It wants to make everything black and white. It's going to happen or it ain't, like my little brother, right? But this just means the probability of that is really low, which is a possible indication of evidence of something. Is it definitely a proof of something? Oh, hell no. You never get that, unfortunately. It's just like in life. You never get 100% proof.
Except if
Yes.
it's huge.
So 100% of the data is found within.
Theoretically, 100% of the data is found between negative infinity and infinity.
All right. Okay.
Yes.
I would clear that up.
Now, obviously, if your data is like heights of people, then you can't go below 0, so you're not talking negative infinity. So that's why most things are only approximately normal,
Yeah.
because theoretically, the normal curve keeps going forever. It doesn't ever hit 0. It just keeps getting smaller and smaller. Yeah. That'll freak you out a little bit. It's asymptotic to the x-axis. No. Infinitely asymptotic. Yeah, it's asymptotic. All right. Is this decent? Any questions from this little handout here? This is section 4.3. This will not be on the quiz tomorrow. Didn't like it? Let's take a break. Let's take a break. Come back at 20 past. We got a lot of shit to get through today.